This is a video lesson for 4.1. We're going to be learning how to factor using a technique called the greatest common factor. Before we do so, we're going to review a few forms that we can see quadratic equations written as. The first form that you're familiar with is the standard form, which is the form y is equal to ax squared plus bx plus c, where c is a constant. You can also see quadratic relations in a different form called the factored form, where y is equal to a x minus r, x minus s, where you can use r and s to find your zeros. So different forms are useful for many different things. Now you can convert from one form to another. You can go from the standard form to the factored form and from the factored form to the standard form using different techniques. So below we have a factored form over here, and we can convert that factored form to a standard form by expanding. So to go from factored to standard form, you expand. And so in this case, we're going to have to use a technique called FOIL, first, outer, inner, and last, in order to expand this expression here. So we're going to have y is equal to our first terms multiplied, so x and x over here, so that's x squared. Remember your exponent rules. The outer terms, so x times -4, that's -4x. The inner terms, -3 times x is -3x. And then the last terms, -3 times -4, which is +12. And then you can simplify, clean up by simplifying with your like terms. So we have y is equal to x squared, -4x minus 3x is -7x, plus 12. And so what we just did there is we went from our standard form to our, factored form to our standard form by expanding using FOIL. Now you can go the other way around. You can convert from the standard form to the factored form. And to do that, you don't want to expand. You want to do the opposite of expanding. And the opposite of expanding is basically doing something called factoring. You factor. And so what does factor mean and how do we do it? We'll take a look at that in just a second. So to factor, that means you're expressing an algebraic expression as the product of two or more terms. Factoring is basically the opposite of expanding. In expanding, you did multiplying. You were multiplying. Whereas in factoring, that involves dividing, because as I said, they're opposites of each other. So in order to factor an expression, if you have standard form, for example, or any expression, you need to find something called the greatest common factor. The greatest common factor that we're going to call the GCF. So the greatest common factor is the largest number or variable, a combination of it, that can divide evenly in all the terms that you have. So we're going to do an example together. We're going to see how we can find the greatest common factor in a set of terms that are provided to us. So these are the major steps that you want to use in order to find the greatest common factor. We have some terms provided to us. We have 3x, 6x squared, and 12x cubed. Our first step is to find the largest coefficient that divides evenly in each of the terms. So we don't want to end up with any decimal values or anything. We want to end up with nice whole numbers in this case here for now. We have coefficients, so the numbers at the front, 3x, 6x, 12. I want to see what the biggest number is that can divide evenly into each of those. So if we look carefully, you don't want to choose something like 2, because that'll give you, for example, 1.5 if you do 3 divided by 2. It works for 6 and 12, but not for 3. You could do 1, but I don't think that's the largest number that will divide evenly into all of these. So if you look carefully, it looks like 3 is the largest number that will divide evenly into each of those. So if you do 3 divided by 3 over here, that's going to be 1. 3 divided by 2, 6 divided by 3 over here, that would be 2. And 12 divided by 3, that would be 4. So 3 looks like our largest coefficient. Determine the variable that exists in each term. So if you look at each of the terms, we have 3x, 6x squared, and 12x cubed. And the variable that's common in all these terms is x. And then afterwards, what you want to do is figure out, well, what's the smallest degree that appears in the variable in each of the terms? And it looks like the smallest degree, we have x, x squared, and x cubed, is this x over here, x1. Remember, when there's no number written on top, that's an implied 1. So 1 is the smallest degree. And what you're basically doing is you're putting these together to come up with your greatest common factor. So in this case, the greatest common factor, or GCF, is going to be equal to our coefficient, our variable, and then raised to that power we discovered, to the power of 1. So 3x. That's our greatest common factor in this case. And so in order to actually factor an expression, you need to know how to find the greatest common factor in those expressions, and we'll do some more examples together. So here we have some examples where you need to find the greatest common factor among a set of terms provided to you. And you can follow the same list of steps that we just did in the previous questions. So example 1, we have A, B, and C. I would recommend you pause the video, try it yourself first, and then come back to see if you're on the right track. So I'm going to look for the biggest number that can divide evenly into the set of numbers that I have here. I can't really do 1, again, works for everything, but that's not the greatest number. That's a small number. 2 looks like it could work. Let me just try again. Does 3 work? No, 3 doesn't work because of that 10 there. So it looks like 2 will work out. So 2 is our coefficient we're going to have. Are there any variables they share in common? There's no variables that they share in common. So no variables that they share in common. And as a result, there's no degree that I'm going to have on that variable since they don't share the variables in common. This has x, this has y, this has z. So really, in this case, our greatest common factor is just is 2. For B over here, let's take a look at the coefficient first. What can divide evenly into each of these? It really looks like the only number that will divide evenly into each of these, in this case, is going to be 1. So our coefficient is going to be 1. Now, do they all share a variable in common? They do, and it's that x value. And what's the smallest degree that they all contain? It looks like it's 2. So our greatest common factor in this case is going to be x squared. And again, because our coefficient's 1, you don't have to put a 1 in the front here. Let's go take a look at C. Let's find our coefficient that can divide evenly into each of these terms. Again, you could try 1, but I think we can go a little bit higher than that. You can try 2. 2 would work because 4 divided by 2 is 2, 12 divided by 2 is 6, 8 divided by 2 is 4. But is there anything else we could use? Not 3. Looks like 4 would work. So if you do 4 divided by 4, that's 1. 12 divided by 4, that's 3. 8 divided by 4, that's 2. So 4 would definitely work in terms of a coefficient. Is there a variable they share in common? Yes, there is. It's a. And what's the smallest degree that they share? Well, 1. This is a to the power of 1. So that means our greatest common factor in this case, we'll start off with our coefficient first, is 4, and then our variable a, and then to the degree of 1. So just 4a, that's our common factor that we have in this case over here. So what we're going to do now is we're going to take a look at how could we factor? How can we take out the common factor from an expression? So the steps below will go through that, and then we'll do some more examples together, but we'll start off with this example here. So these are the main steps. There's three overall. The first is finding the greatest common factor using the steps that we discussed above. So to me it looks like the coefficient would have to be 4 wouldn't work, 3 wouldn't work, 2. 2 would work. The variable they share in common is x, and the smallest degree they share is 2. So our greatest common factor is 2. And so what we're going to do is we're going to place this, so our greatest common factor is 2x squared. And so we're going to place this greatest common factor outside of a bracket. Outside of a bracket. Like this. 2x squared. What we're basically saying is we're going to take 2x squared out of each one of the terms. We're going to divide it out of each one of the terms. And then that's what's going to determine what's inside the bracket. So divide every term of the original equation by the greatest common factor and place these new terms inside the bracket. Inside the bracket. So I'm going to carry the work out to show you what that looks like. We have 2x squared here. That's our greatest common factor. And I'm going to show you how we're going to get the terms inside the bracket. So initially, we had 4x squared. So what I'm going to do is I'm going to do that 4x squared divided by 2x squared. Because I'm taking it out. I'm factoring it out. So 4 divided by 2 is 2. Then x squared over x squared. Remember from our exponent rules, I'm just going to carry this work off to the side here, that's like doing x2 minus 2, which is x0, which is really 1. So I don't have to put an x anymore. X to the power of 0 is equal to 1, so there's no more x there. That the x squared, in other words, canceled out, so to speak. My next term was 6x4, so plus 6x4, and I'm taking out that 2x squared there. So let me just show you, this went over here. So plus 6 over 2 is plus 3. Now in this case I have, just to show you the work here, this is going to be x to the power of 4 minus 2, which is x squared. So I'm going to have 3x squared over here. And then lastly I had minus 12x cubed. Just to show you that's where that came from. So divided by 2x squared. So minus 12 divided by 2 is minus 6. Then x cubed over x squared, that's x3 minus 2, which is x to the power of 1. So just minus 6x. And so what I've done here is I've factored. I took out this greatest common factor from each term by dividing each term by the greatest common factor. And to check your work, you can always go back and expand to see that you end up with the same expression that you had at the beginning. So you could go in and expand by multiplying each one of these to see if you end up with the same thing. So for example, if I want to check my work, I'm going to do this just in a different color in red over here. I would do 2x squared. Whoops, sorry about that. Let's remove that. Back to a different color here. I would do 2x squared times 2, that's 4x squared. That would work out. 2x squared times 3x squared, that's 2 times 3 is 6. X squared times x squared is x to the power of 4, so that's 6x to the power of 4, good. And then 2x squared times negative 6x, that would be 2 times negative 6 is negative 12. And then x squared times x, that's x cubed, so negative 12x cubed. And that would end up giving us the same expression that we had to begin with, so that means we factored it properly. So we have example number 2 over here that you can go out and try yourself. Try it, pause the video, open the next video to see if you're on the right track once you're done, and then we'll do a few other examples in different cases together.